everyone, and welcome back to Dev Show. My name is Sherry List.
And I'm Rasmus, and welcome to this 18th episode of the Dev Show. So we have an interesting topic today again, Sherry. And if you follow some of the other shows, you also know which topic we're going to talk about today. Before jumping into both the content of the session today and also the speaker intro, Sherry, is there anything that you want to share with the audience before?
Yes, I want to remind you all that all of you are going to get one of the Azure Heroes Learner badges. And we are going to highlight the instruction and on the chat and also on the screen how you can get that. And we want you all to interact with each other and also let us know that where you are actually watching us from. You can also write your question in the chat, but we are going to ask it from the speaker and he's going to answer them. But one thing is that when you're typing the chat, please have kind of code of conduct in our code of conduct in mind. It is highlighted in our main meetup page, so please familiarize yourself with that. And we want your feedback. And we are going to share the link with you as well. And remember that one of you, just as always, that filling up the feedback form is going to get a surprise package from us as well. So with that, Rasmus, tell us about the topic.
Yeah, definitely. So the session title today is Sustainable Software Engineering, Building Carbon Efficient Applications. So I assume that all the developers with green hearts and the sustainable minds, they will love this talk. I really love the sustainability topic myself, but not getting into that. In today's talk, our speaker is gonna cover a set of concepts. So you need to understand before you can make intelligent decisions about applications to reduce carbon emissions, things like electricity, carbon intensity, and energy proportionality. So that's some really interesting and important topics, across all industries. But if we can put them into software development as well, that's just going to be amazing. So Sherry, the speaker today, you want to have a chance to introduce the speaker?
Yes, the speaker today is Asim Hossain. And I happen to know him for quite a long time. I just remember today that the very first time that we met each other, Asim, it was in Copenhagen when I was co-organizing the very first NG Vikings. So I know Asim back from the Angular community. That's how we met each other. And I know him. He's creating content for a long time. I totally remember I learned a lot of things, Asim, actually from your very first Angular course that you had for free online. And yes, so he's been working, actually contributing to the community for a long time. And as today, he's leading the Green Advocacy team at Microsoft and focusing on this important topic that we have. So I know that Asim, you are very much these days into gardening. And we had a lot of conversation with each other about planting tomatoes. And yes, so this is one of your passion these days. And yes, anything else, Rasmus, you want to add?
I just want to ask Asim. So with you also told that when your name is being transcribed, for example in Teams call and other places, what is it normally being transcribed to? Can you share a little bit about that?
No, just once when I was on the online platform I was teaching at Udemy, they added automatic subtitling. They transcribed my name to awesome, which is quite a lot of fun. I changed my handle to awesome at work for a month, but then my boss told me to change it back to Asim.
Yeah. I mean, it's not the worst thing to be transcribed to, right? So,
not bad.
and we will see in this session that it's actually true, right? So other than that, no, I don't have anything. I think we should give the stage to you, Asim, and you can go ahead with the introduction or the
Actually, I
presentation.
want to mention one more thing before we give the stage
Sorry,
to
yeah.
Asim. That I forgot to mention that that Asim is also co-organizing the climateaction.tech, which is one of the biggest community right now focusing on the climate. And then the other one that you're also hosting a podcast called theclimatefix.com as well. That I listened to some of the episodes there. One about the electricity map that was very inspiring as well. So yes, so we are going to share all of this link with you all later on, so you can follow Asim and all of his great work. The stage is yours, Asim.
Awesome. Thank you so much for the wonderful introduction. And the podcast is on pause, as is quite a lot of my life right now, because I'm renovating my home in the middle of COVID, in the middle of lockdown. So it's quite complicated. So I haven't got a home studio. So fortunately, I'm in a co-working space. And Sherry, my gardening skills have failed me dramatically. I left this out in the cold, so I'm a learning gardener. I wouldn't say I'm an expert gardener yet. Yeah, so thank you so much for the introduction. So as we're saying, my website, you can go to my website, asim.dev, and it'll kind of link out to all my other social media profiles and whatever you want to follow me. And yes, I'm a what's called a green cloud advocacy lead at Microsoft. And I suppose my role involves both figuring out what it means to be a green application in the cloud, or just generally a green application on any platform, and also helping to advocate for those methods publicly, with audiences. So this is part of my job. And what I'm going to talk to you today is not just kind of the advice, but also my journey. Like, how did I get here? Like, how did we even start thinking about this stuff in this space? Oh, and this is the title of the talk. So for me, really, the journey started with my son. This is about 2 years ago now. And just before he was born, I received some advice from a friend of mine, which was, he said, ask him, take the nappy changes. If he was born, once he's born, my wife is breastfeeding, so she'd have that quality time in the public time, you're going to be shared with all of our friends and family. You're never going to get to hold him. Offer to take the nappy changes, because then that'll be your one-on-one time with him. And I was like, fine, I'll take the nappy changes. I told my wife, she was more than happy for me to take all the nappy changes. But here's the thing: we're actually quite a green family. We've been kind of recycling, doing all the things we were supposed to be doing for quite a long time. So a few days later, my wife turns around and goes, actually, I've decided I'm going to use cloth nappies. Not disposable nappies, where kid poops in a nappy, you pack it away, but cloth nappies. They're quite advanced these days. It's not like what you might imagine in your head with pins and stuff like that. They've got elasticated waistbands, bamboo inserts. But at the end of the day, you have to deal, with poop, quite frequently. You could do poop like 8 times a day, and you get very, very, very used to dealing with poop. It really doesn't bother me anymore at all. At all. It gets everywhere. It gets in your hands, gets in your hair. Sometimes it'd be on meetings and on calls, and my colleagues will be like, asking, "What's that on your face?" I'd be like, "Don't worry about it. It's just poop." So just get very, very used to dealing with poop. But then, one day, months into this whole process, I realized I had an epiphany. How come I was willing to deal with poop, 8 times a day, in this very kind of visceral, in-your-face way? How come I was willing to do that without even a second's thought, a heartbeat? And yet, I'd never once in my entire career in technology, I'd ever put my hand up in a Scrum meeting, in a technical architectural discussion, in any conversation really, and ask, what is the greener option? I'd spend ages arguing, what is the solution which is has the least chance of introducing a bug? What is the solution that we could implement the fastest? What's the solution which would result in the most performance application? We'd argue for ages about these topics, but never, not once in my work had I ever asked the question, well, between these two choices, which is the greener option? And that set me on a long journey to where I am right now, and realized instantly that there really actually wasn't a lot of information out there. There's a lot of information out there about how to be, from a hardware perspective, how to build data centers more sustainably. But what is the software engineers' options? What's their responsibility? What choices can they make which have a measurable impact on the climate crisis? The very first thing I did was I contacted a friend of mine who's in tech and who's also a member of the Green Party in the United Kingdom, and I asked him, what should I do? Who should I contact? And he immediately said, go join climateaction.tech. And this is an old version of our website. We've now improved the website a lot since then. But excuse me. And this is it's an online community with as Sherry said, we're the largest tech community for climate action in the world. I'm now a co-organizer of this community. If you go join it, it's a Slack group. It's a number of other things. And inside there, you'll find all sorts of people, extremely knowledgeable, who are all on different levels of their journey of trying to, have a positive effect on the world, and just learning as well, like what is the impact I can have. And inside there, I found a lot of like-minded people. You'll see there's different Slack channels. There's one on infrastructure, one on performance, things like that. And those kind of really started to point me in the right direction of, this is how you should start thinking about sustainability with technology. I think these are the things you should look at. These are the things you should read. And that again started me on another 6-month journey. And I was just, if you looked in my office at that time, all I'd be doing is reading scientific papers. It's really a lot of the thinking in this space right now is still very academic. There's still a lot of kind of academic work. There's very few books on the subject, very, very few books on the subject. I've read all the ones I could find at least. And I learned a lot. But I realized I can't expect the next person to come along to do the same amount of research that I put into it to reach the same conclusions that I've reached. We need to make this easier. So me and a few others we sat down, we created what's called principles.green, which is, or the principles of sustainable software engineering. And what you find inside there is 8 principles. These are 8 things that we think you need to understand as a software engineer to have an impact to understand how to best have an impact on the climate. Challenge is the things we're taught to be software engineers, we're taught like a narrow area of focus. But to have an impact on sustainability on the climate, you need to understand a bit broader. I used to think that full stack was front end to database, and now I know full stack, or now I believe full stack is user behavior to how electricity is bought and sold on an energy grid. I mean, or how concrete is poured to make a data center. Like, you need to kind of really broaden your horizons, and if you do, then that's when the really interesting decisions that you can make to have an impact. So that's what Principles Green and the principles try and get you to do, is to try and understand a broader area of computing and just the things that you need to know to be more sustainable. So these are kind of the 8 principles. They've changed a little bit since I took this screenshot, but these are the core principles there. That's what we did in principles.green. Recently, we've just kind of launched this as a Microsoft Learn module, so you can go on there. And the advantage of being a Microsoft Learn module is I can get actual designers to design actual things rather than my hand-drawn things on an iPad. So, and it's got a bit more information there. And we're gonna, and from now I'm wearing a Microsoft hat, whereas we're gonna grow this in Microsoft to be a lot more training and learning about sustainability. There's also a little bit of information here. So we're now also going to be creating very, very specific targeted advice for how to use certain technologies most sustainably. Right now, all we have right now is AKS. This is our Azure Kubernetes service, and it's just some advice there for how to use that more sustainably. And we also launched a blog. It's a sustainable software blog. Really proud of this. It's kind of brought a lot of people together inside Microsoft, and we really just started to. It became a place where we could just start writing about what we're learning about sustainability in terms of software. And inside there, you'll find some really great articles from people. It's not structured. It's just learn A, B, and C. It's more like, this is something I did. This is my use cases. This is how it helps. It's much more around that area. But I'm really proud of the blog as well. But yeah, so what I'm going to do now is I'm going to talk about some of the principles and really try and give you an overview of the things that you need to care about, and kind of the principles of sustainable software engineering. I'm going to have time to go through all 8. I'm going to see how long I have. I've got 20 minutes. I want to see how long I can get to. But I'm going to try and cover as many as I can. Again, if you want to learn more, you can get to principles.green or anchor.ms/sse/learn. But anyway, so the first principle is carbon. So, but the first challenge, and it's quite early on in the stage, the first challenge when talking about sustainability to other people, to other engineers who care about sustainability, is sustainability means different things. It means a lot of different things. According to the UN Sustainable Development Goals, there's 21 of them. It's very, very hard. And at Microsoft, when we think about sustainability, we think it on 4 pillars: carbon, waste, water, and ecosystems or biodiversity. It's really hard to optimize for 4 variables. It's really hard to optimize for 21 variables. So we really wanted to kind of narrow down the focus to just the one thing, the one variable that we're trying to optimize for, and that's carbon. And we're not going to go into big talk about kind of climate change, but essentially, like there is the things called greenhouse gases are warming up the atmosphere. The most common greenhouse gas is carbon dioxide, but it's not the only gas. It's not the only greenhouse gas. There's other ones out there. For instance, there's methane. Methane has about 25 to 80 times the warming effect of carbon dioxide. And there's other ones. There's ones the fluid that goes in air conditioners is almost 10,000 times the warming effect of carbon dioxide. And so then how do you kind of talk about all this stuff? Well, what we do is normalize it into something called carbon dioxide equivalent. So when we call 1 ton of methane, we would call it, say, 25 tons of carbon dioxide equivalent, and that's the way we kind of collapse it all into one unit of measurement. And that often is just collapsed down into carbon. It's just carbon dioxide, it's collapsed down to carbon. But when we say carbon, we're talking all greenhouse gases. And really kind of the way to think about what is the goal, what is as a sustainable software engineer, what is your primary focus in life? And that is to not waste carbon. To not waste carbon. Okay, so we all, throughout our entire lives, everything we do, we emit carbon. Everything we do in society and the way we live these days, you cannot escape it. You're always going to be emitting carbon in whatever we do. But to be a sustainable software engineer, and I argue to be green, is just to be very efficient. For every gram of carbon I emit into the atmosphere, and I accept that I do, I make sure I get the most value from that as possible. And I think a great analogy for this is the difference between an internal combustion engine car and an electric car. So if you look at an internal combustion engine, to get crude oil from the ground and turn into the petrol or gasoline, you actually lose 50% of the potential energy in the oil. It disappears. You just wasted it. To get petrol to the car, you have to weigh something. Right, so you have to move it around. You actually lose another 20%. But an internal combustion engine in a car is only 20% efficient. Only 20% efficient at turning petrol into forward motion. So it's like 8%. So the challenge I put forward, and this is very opinionated after Hussain's opinion, my challenge I put forward is that no one should be proud of being 8% efficient at anything, but The problem is that it's only 8% efficient, I would argue. Right? If we make this whole chain to be 80% efficient, then that changes the whole narrative of what's going on right now, and it would dramatically change the options that we have forward to meet the climate commitments. But right now, the problem is there's so much wastage going on. Let's have a look at kind of from an electric vehicle perspective. From solar energy coming to the ground, we consider that 100% conversion, because we would have lost that solar energy to heat anyway, to just landed on the ground. To move electricity around, you only lose about 2% over very long distances. So it's a very, very efficient means of transporting energy. And an electric vehicle is typically about 70% efficient at turning electricity into forward motion. So why is an electric vehicle green, right? Because it's so efficient. It's so efficient at what it does, at taking energy and moving it forward. So it's so efficient that even if that electricity was created through burning of oil, it would still be more efficient, right? That's the point. So when we talk about being a sustainable software engineer, what we're really talking about is building applications that are carbon efficient. We accept that every application that we build, everything that we do is going to emit carbon, but we focus, our goal is on making sure that we are as efficient as possible with the carbon that is emitted. So it might sound like a really simple, like a long time just to explain kind of one principle, but this was really important in that it enabled everybody to finally get on the same page. So if we're talking to if two sustainable software engineers are talking, you know they're talking about building carbon efficient applications, and one's not talking about water and the other one's talking about something else. We're talking about carbon efficient applications. And the second one principle is related to electricity. I don't know about you, for me personally, in my journey into learning about this space, I used to think of electricity as very clean. I mean, when I plug something into a socket, my hands don't get dirty, there's no smell in the air. So I used to think of electricity very, very clean. But it turns out, in fact, electricity is one of the dirtiest things on the planet. And that's because most electricity is still created through the burning of fossil fuels, and actually mostly coal. So most electricity is coming into your house that you're consuming. Coal was burnt to create it. And so it matters. Like electricity matters. Like I also realized that how come I didn't really know anything about electricity. It's kind of crazy to me. As an engineer, as a developer of hardware, of software, we're completely dependent on electricity, and yet I knew nothing about it. It might as well just be magic juice that gets pumped through the walls, and you say a spell and it plugs into the computer. That who the hell knows what electricity is, right? But of course, electricity is a scientific thing, but I didn't understand what it was. And I think that's something as a sustainable software engineer, you need to understand electricity, because there's a direct line from electricity to burning coal to carbon. So if your goal is to be carbon efficient, your goal is also to be energy efficient. Okay, you need to build energy efficient applications. But what does that mean? Like, how do you even talk about electricity? Again, another thing, I didn't really understand the terms for electricity. Like, what is a watt? What is a kilowatt hour? And it's quite important. So the standard unit of energy is called a joule. And it actually defines like a volume of energy. A watt is a rate. So a watt means 1 joule per second. A kilowatt, therefore, is 1,000 joules per second. But a kilowatt hour is a volume of electricity. It's how much electricity you would have if you ran that for 1 hour. That's how much electricity you would have. It's the volume of electricity. So often hear people talk about kilowatt hours, and what they mean is a volume of energy. And that kind of leads to the second principle of sustainable software engineering, which is that build applications that are energy efficient. Okay. Before you go away and kind of rewrite everything in kind of C or Rust or something like that, just stay on listening to this presentation, because there's potentially some more lower hanging fruit for you there. But yes, fundamentally, one of the best things you can do is to build applications that are energy efficient, that consume less energy to perform the same task. And actually, it's not too crazy a suggestion. That's because most of the time when you're building kind of devices, especially for mobile, for laptop energy usage, it matters, right? It matters how much energy your application is using. So therefore, building application which have better battery performance has a dual advantage, both better for user experience, but also better for the environment. Excuse me. Okay, the third one is carbon intensity. That's actually I understood a lot more about this from a podcast. It's my favorite podcast. It's not my second favorite podcast. It's called the Energy Transition Show with Chris Nelder. There's two facts about this podcast. It's the only podcast I've ever paid for. So it's a paid podcast. I pay for it every year. B, it's the only podcast that I've gone back to episode 1 and gone all the way through. You actually use it. It's used in universities to teach courses. It's a fascinating podcast, and it's talking about kind of this wonderfully interesting transition that's happening right now from fossil fuel created electricity to renewable powered energy. And is that going to happen very, very fast, or is it going to happen very, very slowly? It's a fascinating show, and it gives you a lot of hope for the future as well, I find. But in the show, he taught me the concept of carbon intensity. Okay, as I said before, when I said that most electricity is created through the burning of fossil fuels. So you can imagine, in regions, so basically there's how dirty is your electricity? How dirty is it? What measure do you have of that? Now we understand why I was teaching you all those terms, because this is actually the unit of measurement of carbon intensity, which is grams of carbon dioxide equivalent, grams of carbon per kilowatt hour. So kilowatt hour is a volume of electricity. To get that volume of electricity, how much carbon did we have to release into the atmosphere? And a good way of thinking about this is, because it's difficult sometimes to kind of even think, what is a gram of carbon? Just imagine soot. And if you burn some wood or something, you got some soot in your hand, like that is what you're thinking about. The average for 2019 for electricity was 519 grams of carbon per kilowatt hour. So that's half a kilo of soot for a kilowatt hour of electricity. So all electricity has a measure of how dirty it is, but some really interesting facts come along. So this is a great website. Shrey mentioned it at the start, like Electricity Map. You can go to it and you can hover over different parts of the world, and it will tell you at that current moment in time how dirty or clean is that electricity. So you see, like Germany at that time was 100, Poland was 600, India's not great, Australia's not great. It's pretty bad. This probably is quite a good time in Australia, to be honest with you. East Coast US, it depends. It's usually pretty bad. West Coast, it's usually better. But it depends very, very much on the specific utility that's providing electricity in a grid, in a region. So now you might understand that actually different regions honestly have cleaner or dirtier electricity, just based on the fact that that region has more fossil fuel power plants, and that region has more renewable or low carbon power sources. But France has incredibly low carbon intensity. That's mostly because France has a huge nuclear fleet. So it's kind of different things you can take advantage of that. So that's something you can do. You can just run things in regions that are cleaner. But another really interesting thing about carbon intensity is that it changes over time. So let's imagine in this kind of one moment, there's this much demand for electricity. Oh, another thing I should mention is that there's no batteries on the grid. There are some batteries, but they last for minutes. They're just for very, very short-term storage. Like if you switch on a kettle at home, typically utility has to make just enough more electricity to give you a kettle the electricity it needs. If it doesn't, and it doesn't provide enough electricity, there's brownouts. So it's typically if you're using more electricity, the utility quickly has to ramp up and give you more electricity. If you're using less electricity, it also has to ramp down. If it pumps too much electricity in the grid, blackout. So there's a constant balancing action happening real time in grids. And that makes renewables really, really interesting and really challenging for them as well. So wind and solar is free energy. Like, you would always take that electricity if it was given to you because it's for free. Like, why would you not have that? But coal and gas, because you have to burn, you probably don't want to burn it. So at times when the wind and solar is available, you might only have 120 grams of carbon per kilowatt hour. Then the wind dies down or the sun stops shining, but the utility still has to produce the same electricity. So it burns more coal, it burns more gas. What that means is over the course of a day, your carbon intensity also increases and decreases. So even within one region, it increases or decreases. And that means it gives some very interesting options as an engineer, right? Because then you can choose where to run some things, places which on average have better carbon intensity, or if you can't move it, maybe you can pick a time. If you've got a batch job or something which can run it in a short space of time, maybe you can pick a time when the carbon intensity is lowest. It really depends on region by region when this is going to be, and on situation by situation. And there's moments in the world where there's so much sun and there's so much solar, and this situation happens that it's essentially 100% carbon, zero carbon energy at those moments in time. So there's some things you can do. There's various sources you can get this data from. In the UK, I'm very lucky we have one called carbonintensity.uk, which is free to use 100%. What Time is a non-profit based in the US, and Electricity Map is a startup based in France. And they have data for all over the world. I argue What Time has slightly better data for the US, Electricity Map has slightly better data for Europe. But there's some kind of three sources of carbon density. These last two you have to pay for. Although they have like free tiers as well, so you can check them out. But there's some various sources of carbon intensity. Hopefully, maybe I have time for one more. Oh, that leads to the third principle, which is consume electricity with the lowest carbon intensity. Actually, the really exciting thing about carbon intensity is that it's something you can do as an engineer, or not even as an engineer, as anybody in tech, because you don't need to change any code. You might not need to change any code. It's just a decision as to when and where you run software. Just that decision all by itself can reduce the carbon emissions of your application, which makes a very appealing choice in a number of scenarios. Also quite challenging as well, but anyway. So I think I have this chart. So this is an event that you do in real life. This is like, we used to do these. They're quite interesting. But I was giving an event once at a conference, and you can see I was giving a talk at a conference, and you can see I was probably talking about something to do with climate change. I think it was an earlier version of this talk actually I was giving. And I remember afterwards there was after these talks, people stand and they ask you questions. And there was a guy, and he waited for ages to speak to me, and then finally got to the front of the queue, and then just said, great presentation skills, but you used a laptop, so I don't believe anything you said, and then walked away. And it took a while for me to figure out what he meant. And I get this attack so often; it's funny these days. But it's like I'm not allowed to have an opinion on sustainability because I used a laptop, and because in the creation of the laptop it emitted carbon, and therefore I am not allowed to say anything about this. This is such a weird whataboutism fallacy. And it's also why I say, like, it's not about that. It's about carbon efficiency. It's not about not emitting carbon. We're always going to emit carbon. It's about making the most value of every gram you emit. But the guy was talking something real. There's this concept called embodied carbon, which is every device, everything in this planet emitted some carbon when it was created and will emit some carbon when it's destroyed. And that term for that carbon is called the embodied carbon. And it can be quite significant. But really, as a software engineer, like, what can I do? There's nothing I can do. Like, it's already gone in the atmosphere. What can I do as a software engineer to change that? And I think the one thing you can do is to really try and lengthen how useful hardware is, and that's what we do have an impact with. because really most hardware doesn't really die. Like the servers, servers don't really fall apart. There's no moving parts anymore. They just run, and then at some point we decide that they're too old and we end of life them. That's typically what happens. Sometimes they go faulty, of course, but like typically they just end of life them. So let's say we have and so what we do is we kind of say, well, let's assume a server has a lifetime of 4 years, and 4 tons of CO2 is released in creating the server. We would then spread those 4 tons over the lifetime. I would say maybe it's a ton a year or 80 kilos a month, something like that. If we were to spread that over 5 years, if we were to somehow make devices just be useful for longer, that's what we can do as software engineers to spread out the kind of cost of that carbon. And that's what we call, that's why the 4th principle is to build applications that are hardware efficient, because hardware, right, to bake this hardware, you emitted carbon. So there's a direct line from this device to carbon. And if our goal is to be carbon efficient, our goal is to be hardware efficient. We don't want to be throwing these things away. We want to make sure they run for longer. Does your software have to max out the latest version of every device? It doesn't. Build for older hardware. It also has a lot. It also speaks a lot to inclusivity, and there's a global people all over the world who don't have the latest hardware, so you need to speak to them also. Hopefully, we'll reach this last principle, which is really interesting as well. It's called energy proportionality, and for me, this is fascinating because this involves hardware, and I'm not really I was never that comfortable with understanding how hardware works underneath. I used to think that if I was using my laptop, or let's say a server, if I wasn't using a server at all, if it was 100% idle, I used to think it probably wasn't consuming that much electricity. When I was maxing out 100%, it would consume a lot of electricity. And I used to think it was almost a straight line in between those two, like proportional. It turns out it's not proportional. It's very unproportional. Even when your server is idle, it often consumes a lot of electricity. And that's because most things on a server consume electricity regardless of how much you're using it. Memory, doesn't matter how much you're using it, consumes the same electricity. Network cards, doesn't care how much your data you're shipping through it, still consumes the same electricity. CPUs scale, but each core in a CPU has a static amount of electricity. It consumes all the time, whether it's idle or 100% in use. The more cores your CPU has, the more, it's called a static power draw, the more static power draw it has. And what this means really is the more you use hardware, the more efficient it becomes at turning electricity into useful operations, the more you use hardware. And so from like a software deployment perspective, what this would mean is like if you were to use 2 servers and only utilizing 50%, it would maybe, this is all made up numbers, it would maybe use 360 watts. But if you were to run those exact same processes and max out a server, it might only use 200 watts. So there's this really interesting aspect of energy proportionality, which is really important. And I think the global average of server utilization is between 10 to 15% across all clouds. I believe that's all not hyperscales like Microsoft, but all kind of on-premise clouds. There's a big challenge there. It's actually one of the, if there's one area to focus in on is just trying to max out your server utilization. You're probably going to have the biggest impact with your effort there right now. And that's why kind of the 5th one is to maximize the energy efficiency of hardware. And there's other really interesting things that you can do there. Like what a laptop does is laptops and other devices will actually change the frequency at which the CPU is running to make it more energy efficient because they care about battery life. There's lots of things that you can do from a software perspective to control that to maximize the energy efficiency. Okay, I think I'm reaching the end now. So just to there's other principles, and we have more depth. There's much more depth on them, and you can find them all on that Learn module at the top. As I said before, we have a blog now where you can find more kind of really interesting practical examples of how that works. He's just put an excellent article up there on Monday about how to do green progressive web applications, if there's web developers there. But he's done some really interesting work on that. Really interesting work on that, actually. You should read the article. As I said, Debbie, we've got some docs, not much, one on AKS there. There's a really great conference happening in France earlier on this year called greenconf.io. All the talks are online, and there you'll find a bunch of talks, one from me, but also from a number of other people there. And I recommend you kind of like, if you want to learn a bit more, that's a great place to go also. But the primary thing I'd say is to go to if you just want to get like a quick summary of all of the principles, I'd head to the Learn module there. I think that's the end of my talk. I'll leave this screen up for a little bit for if people want to take screenshots or something. But yeah, if anybody's got any questions, I'd love to answer them.
Great, Asim. Thanks for this. Really awesome principles, and yeah, I could just imagine if every developer was following those, it would change the at least some of the world, right? So that's amazing. I really enjoyed it. Have some questions just to get started with here. So we were just before we were going live. Then we were talking about what is the challenges or what is the plans for sustainable software engineering in 2021. So next year. So can you elaborate a little bit on that?
The plan, at least from my side, and it's not just me. The plans from where I'm sitting is to build up a lot more content and documentation. On a lot more training on the subject. So I just covered the principles there. We plan on creating more in-depth content on each and every one of those principles, like really dig a lot deeper into energy proportionality, really dig a lot deeper into energy efficiency, and carbon intensity and these other topics to kind of explain what's going on there. Other things I'm kind of like looking at with others is, this is great and fantastic, and it's really interesting, and we've coming at this from a what can like an individual engineer do in their company, but also kind of try to look at it from kind of the CTO perspective down, like how can somebody who's looking at things from that kind of broad perspective make sustainability a priority in the whole technology area. So we're looking at things like a maturity model, like how do you actually score an application for sustainability? Like what is, how would you score that? What would you even measure? How would you know how to get it to the next level? What are some kind of methodologies that you need to employ, like almost like a DevOps approach, what is the sustainable ops approach to all of this as well? Maybe that's I think we just coined a term there, sustainable ops. It's the first time I've ever said that out loud. I like it. But that's kind of some of the stuff we're going to be looking at next year. Expect more kind of conferences and a lot of stuff. Hopefully we're going to be doing it as open source as well. We want to do this like everybody in Microsoft is working on this. We want to do this in the open, really collaborate and kind of it's not about like just it's about making every application better, not just kind of Microsoft applications, even Microsoft applications on the Microsoft platform. Like I don't care. We need to make every single application, every single platform, and every single cloud more sustainable. So that's some of the stuff, fingers crossed, you're going to see in 2021.
Yeah, that's amazing. And that's as you say, it's for the broader application development, not only Microsoft apps. So that's amazing. And
we have some comments. I wanted to highlight it as well. One of our attendees, actually Martin, Halse, he mentioned that I heard about water cooling servers and using heated water for instances in district heating. Seems like an obvious carbon efficiency hack. I would love these implemented widely.
So there's actually what he's talking about is one of the biggest. This isn't from a software engineering perspective. This is from a hardware engineering perspective. One of the biggest sources of consumers of energy in a data center is just keeping everything cool. And so the problem is we're using air to keep things cool, right? And it's not the best medium. So you can actually you can even partially submerge a server into a liquid, not water. Don't try and put it in water. Well, there's some really cool video where you submerge an entire server into a liquid of some form, and it allows the heat to dissipate much more efficiently. It's all about efficiency, right? So it's much more efficient dissipation of each. It basically costs you less electricity to keep everything cool. And I think again, it's just an example of it's about carbon efficiency, right? Anything that you take, even if it's 1% improvement, your carbon efficiency gives you a path forward and a direction to go in. So yeah, it's really exciting stuff. Emerging technology. I'm excited about it. But I would also say that we can't. This is what I would also. I want to do something as well. To be honest, like I think I have a certain responsibility when I write applications to write them, sustainably, and I wanted to know what that was, and that's kind of where we're going with this. Is there's lots of things you can do, but like let's just get the advice together for software engineers so they can figure out what to do to make their applications more sustainable as well.
Exactly. So if I'm just standing here thinking, if I were the developer and I wanted to get started on making sustainable software development from tomorrow, but I want to choose the path and the area where I would have the greatest impact. So if I could not embrace everything that you gave a lot of good advices here, and you touched upon a lot of great principles. But if I were to choose a smaller kind of subset of it, where I have the greatest impact, what would you say? Where would be my starting point?
Well, the thing is, I left some slides off that were quite important. I just realized because there's also two philosophies of sustainable software engineering, which I left those slides off. I'll remember that next time. So the first philosophy is everybody has a part to play. Everyone has a part to play. One of the challenges I've had kind of working in this space is that a lot of the advice of the past was for a very niche aspect of computing. And so if you're like a front-end engineer and you're sitting in a company, it's like, what do you do? It's the way we expressed it in the past was like, you don't worry, we're not talking to you. We're only talking to that person over there. And I think that was a mistake. I think what we need to do is every single person in whatever domain you're in, whatever part of the technology stack, that there should be something for you to do. And so that's the first philosophy, and the second philosophy is that sustainability is enough. So everything that we do, a sustainable application, a green sustainable application is almost always cheaper. It's almost always faster, and it's almost always more resilient, right? But they're not the reasons we do it. The reasons we do it is because we care about sustainability. We may use those other reasons to argue for some things, but the reason we're doing it is for sustainability. And so what that means is kind of what's the advice that you could give to somebody? It really depends on kind of where you sit, because some of the principles might resonate more with you than with someone else. So for instance, if you're more like a mobile app or a Windows engineer or desktop application engineer, the principles that most resonate with you are typically the energy efficiency and the carbon intensity. And there's also probably directions you can go in there. I recommend going to the Sustainable Software Engineering blog. There's two really great blog posts. Pierre Legrand wrote one about how he worked with the VLC to help make the VLC application more energy efficient. And then David wrote an article on PWAs. So it's kind of like how can we make them more energy efficient, because that's what they care about. If you're a front, and I also want to if you're more like on the front end design side of things, obviously there's the networking principles, and that's all about, we didn't cover that, but it's about one of the causes of carbon is just data going across the network. So then you care about reducing your emissions there. But at the same time, we have demand shaping, and if you're a designer, if you're architecting the user experience of an application, there's decisions there you can make which have an impact on carbon as well. And there you go into demand shaping. This is a great question, actually. I should probably write, like, if you're in this role, these are the principles that probably are a priority for you. Is a great idea for a focus area. But yeah, unfortunately, it depends on what area you're in. If you're on the server side, it's all about the energy proportionality. Pretty much, right? It's all about, as I said before, 10 to 15% average server utilization. If you were to double that, you're essentially doubling the carbon efficiency of your application. Right? If you just make your servers 20%, it's crazy to me, but 20% utilized instead of 10% utilized. And you get to like 50, 60, you've just made like a 2, 3, 4 times improvement. I mean, it's difficult to get those kinds of improvement in those other areas, in those other principles, but it's very easy to get that in the energy proportionality one.
Definitely. Yeah, thanks for that. I really love that answer. So really broad and also it depends, but also details. Thanks for that, Asim.
And I can see in the comments, many people like that sustainability ops term.
Nice. Here it is. We know where that term was birthed. In like 10 years' time, we'll look back at this moment.
Yes, I guess we should wrap it up, Rasmus.
Yes.
There are a lot of good feedbacks about the talks in the comments. I will share them with you later on. But let me.
Definitely, and I also hear that this is something that could actually take one more episode of Dev Show, right? So going in more into depth of something here. So let's also talk about that offline, Asim. That would be lovely.
Yeah.
So yeah, as we got a lot of feedback in the chat, but we would also continue that feedback to come in. But if you want more anonymous feedback, please use our form with this QR code, both in terms of what did you like about this session, what should we do more of, which topics do you want to have in the Dev Show, or even if we should invite Asim back for a session on some specific areas from this talk, right? So if there's anything you would like us to go even deeper into, then we can see if we can convince Asim to come back. So please fill out the feedback form, and you can also use our Twitter handle and the chat window, of course.
And also, you can win something from it as well. That is also.
Sherry is playing Santa Claus.
Yes, and also there is a specific part that you can actually give a direct feedback to Asim as well. That we definitely will share that with Asim later on as well. And the Azure Heroes. Yes, if you haven't clicked on that the link that I shared, you can scan this QR code and have your Azure Heroes there. Follow the instruction, and you can nominate yourself for the other actually badges that we have. And we have one which is also a green developer, green contributor, And one thing for all of you to know, since Asim is a domain expert in this area, so whenever that we receive any kind of that request nomination for this green contributor, it goes directly to Asim. So yes, he's helping us with this, and I should thank you, Asim, on behalf of the team for your help. And yes, you can, when you are owner of one of these badges, you can go to the Azure Heroes community and add yourself to the map as well, if you want to. And then you can also discover the others around you that they are having multiple of these different badges as well. And what do we have for
Yeah,
next?
what's coming up here? So we are staying in the green path, right? So next week we have David here talking about building the green PWAs, as Asim also slightly touched upon. So we're gonna go more into details in that area next week, and then afterwards. Last time we talked about this is gonna be a surprise episode of the Dev Show, the last episode of 2020, the 15th of December, and we're actually gonna have Vasim on the show there, and he's gonna talk about how you can actually control a coffee machine with your brain, and you can just leave it hanging in the air if it's a dream or reality. Imagine you're just thinking about a cup of coffee, and suddenly it's been made, right? Who don't want that to happen?
Yeah.
So that's going to be there, and as always, Sherry is going to have something in as a surprise. There will be some giveaways, etc., etc.
Yeah,
It will be a festive session.
yeah, that is going to be very close to the end of the year, so the Dev Show is going to be to hand out a lot of different swags and so on, and we are trying to be sustainable as well. So we had the sustainability December. So yes. And then for those of you that you are you know about this conference, Virtual Azure Community Day on 3rd of December in 2 days. We are going to be live with 4 tracks from 10 o'clock in the morning till 22 in the evening. Yes. You want to say
Asim?
something?
No, I forgot to give a shout out to something. Well, after you finish, can I make another announcement? Finish, I think. Sorry.
Yeah, yeah, you can go now.
Okay, so I forgot then. So we just launched. I was going to make a shout out to say at the same time we are planning a TEDx event. TEDx Climate Action Tech. I should put the link up, but hopefully if you Google it, you'll find it. Or I can post it somewhere. But yeah, it's going to be on the 16th of December. We've got a number of speakers, and there's going to be speakers. We've got all over, but essentially about how do you transition the tech industry, and how do we make the technology industry more sustainable, and how do we use technology to make the world more sustainable? So there's going to be a bunch of talks by some very, very exciting speakers, and yeah, TEDx Climate Action Tech.
Wow.
I'm going to put it to the kind of follow-up emails if you send the link to me, and I'm going to share it with everybody. Yeah, I remember I saw that. I guess I saw it on Twitter recently, an announcement about it. And the other event that we have is Create Data. That is all about the data and AI on December 7th. That you can just register on aka.ms/create data. That is also pretty interesting conference, and a lot of well-known speakers are going to be there as well. So don't miss it. Don't miss this one. And as usual, you can always contact us. The best way is on Twitter, and our DM is open. And I would just say that see you all next week on December 8th.
Thanks, Asim, for being on the Dev Show. Thanks for the great presentation, and thanks for everybody for listening in.
Yeah. Thank you.
Thanks for having me. Thank you so much.
See you.
Bye-bye.
Bye-bye.
Bye.